Hello, my name is Peter Aronson. I'm a professor of medicine and cellular and molecular physiology here at Yale University, where this is being recorded on April 23rd, 2008. It's my pleasure today, on behalf of the American Physiological Society and Yale University, to interview Gerhard Giebisch, who's the Sterling Professor Emeritus of Physiology at Yale University. Dr. Giebisch is internationally known for his many contributions to renal physiology. He's one of the true giants of the field, and it's for this reason that he's the subject of this interview about his career. So let me introduce Dr. Giebisch. And well, I guess we'll begin at the beginning. You were born in Vienna back in 1927, right. And the roots of what we do are sort of set by our family environment. And I wonder if you could say something about your parents and what sort of thing they did and how that might have influenced you for your eventual career.
Well, I was the only son of my parents. My father was a professor of French literature and German literature, taught high school. My mother essentially had a somewhat unusual early life period. She grew up in Romania, where her father, at that time in the Habsburg Empire, was in charge of an electric power plant. She had a French nurse, so she spoke French quite well. And I think some of the artistic interests that I have developed may be due to my mother's influence. My father was a very kind and very erudite teacher. He had a lasting interest in history, which he sort of conveyed to me in some ways. And we had a very, I would say, quiet early life in rather modest circumstances. We had a two-room apartment for many years. I went to a private primary school and then did the usual high school in Vienna. This was interrupted more or less at my age of 16 during the war, when daily bombing raids sort of made the educational process somewhat less than perfect.
And then you, somewhere along the line, decided to apply for and attend medical school. Was that originally motivated by a desire to be a practicing physician, or how did you decide to go to medical school?
Well, I've asked it myself. It was a rather, I think, haphazard decision. But looking back, I think it was probably the influence of two of my relatives who were physicians. My uncle from my mother's side was a very well-established dermatologist in Vienna, sort of with a very illustrious career and practice, and I think I was very impressed by him. That sort of was something that had left a deep imprint in me. And the other one was sort of the opposite, was a practitioner in the countryside who, about an hour west of Vienna, who, as one of the few people who owned a car, and I think that also impressed me at that time. So I think it was these two early sort of role models of medicine that made me to go to medical school. But the situation, of course, when I started medical school in Vienna was very chaotic. It was actually at the beginning of 1946. The city was partly bombed. It was occupied. There were a huge amount of students. And I just started medical school more or less because of a vague interest, and that seemed an interesting thing to try out. Although switching, studying was not likely in those days. You usually started something and stuck with it.
So it's fair to say that your initial motivation to attend medical school wasn't to become a physiologic scientist.
No.
So somewhere along the line in medical school, I know you came under influences of different professors who then did help develop your interest in physiology, and I wondered if you might comment on that.
Well, the whole medical education was totally different from the United States. My entering class was 1,800. A lot of people returning from the war years, but it has not changed that much. By the way, the medical school attendance in Vienna is still extremely high. So I started as one of 1,800 in 1946, and the classes were just huge. There were lecture rooms with microphones outside to accommodate a large number of students. And on the whole, it was a very intensive time in my life. Despite the rather impersonal character of the educational process, there were several of my teachers that left a deep impression upon me. Somehow they conveyed the idea to us that what you were doing was important. And somehow that caught on to quite a number of my colleagues, and we took studying quite seriously. Two individuals in particular, maybe three, were important. I think the most I think influential person was our professor in pharmacology, Professor Franz von Brücke. Came from an old academic family, was a very highly educated person who gave fantastic lectures in actually, I think, applied physiology more than sort of classical pharmacology, and I think that left me very interested in the field. There were daily lectures for 2 semesters, so many of ours at 2 o'clock in the afternoon, but we stayed awake. He had a really superb way of making things interesting, and I kept a relationship for many, many years. Actually, once wanted me to come back to Vienna and become interested in the physiology chair there, but I did decide to stay in the States. But he was very, very important. Now, originally, I wanted to go into internal medicine, and that got me in close contact with another individual whom I owe quite a bit, Erwin Deutsch. He was had a section chief in one of the internal medicine clinics. He's a very stern person, very, very serious, and again, there was no funny business going on there. But one of the conditions of being accepted in an academic clinical department was to spend 2 years in the basic science department. So I chose, as you might have expected, pharmacology, and stayed there for a year. I had a couple papers. Actually had an early paper on renal function and the site of action of diuretics, which happened to be, came out more or less correct, although it was a very indirect way of approaching it. And Sam Rappaport, who was a nephrologist who came back from the States, was one of my early sort of renal mentors.
So still at that time, you were doing a couple of years of research as a means to an end of getting clinical training,
right.
But hadn't yet committed to a research career at that point in time, I guess.
Right.
And then your specific interest in renal physiology. I know somehow or another as a student you came across the writings of Homer Smith, and maybe you could tell us about that.
Well, I was always sort of impressed by books, and I think that leads me to really what I owe to Homer Smith. Homer Smith was an important renal physiologist, and maybe we can come back later to his major contributions. But at that time, he had apparently published a book that got to me roundabout way. It's just as interesting. One of the professors in internal medicine, whose wife was an American, had brought back from the United States a collection of Homer Smith's lectures, the Porter Lectures it was called. And since I attended his specialty course actually in cardiovascular internal medicine, he let me have the book. And there it was. I mean, I remember distinctly that that was an important book in the sense of acquainting me with renal clearance methodology that Homer Smith reviewed as applied, as a matter of fact, to a group of hypertensive patients. You could measure filtration rate, blood flow, and correlate them with reabsorptive capacity, and came up with factors that represented either glomerular lesions or tubular lesions in hypertension. And that was it. In other words, I was extremely impressed by that, and started my interest in renal physiology.
So with that interest in renal physiology starting, how was it that you decided at a certain point to come to the U.S. for training and really make that your career? Here you were a student being exposed to Homer Smith, but what happened next to actually cement your bond with renal physiology as a career?
Well, having read material by Homer Smith, I ran across another book in one of the bookstores in Vienna, was entitled Modern Renal Function Tests. And that was by a Swiss internist who lived in Zurich. So I wrote to him, and he actually accepted me as a medical student. That was in 49, I think, or 50, for 3 months. This is a rather unusual arrangement financially. Obviously, I didn't get any pay for that, but I had to live somehow. And I remember distinctly that I was sort of visited several Viennese expatriates who would give me lunch. So I went to various places to be fed, sort of, and had a very simple way of life, but thoroughly enjoyed it.
You had sponsors.
I had sponsors. That's right, I had early sponsors. It was actually through a friend of mine who worked there as an optician who arranged this for me. But it was good that again acquainted me with clinical application of renal function tests, and that I think at that time I decided to stay with renal physiology, or with nephrology. Also, it was apparent from my stay in Zurich that the development, its whole methodology, was simply taking place in the United States, and that kindled my interest to look at that possibility to further training in the United States.
Now, of course, at that point, here you are a student in Europe. You didn't really know anybody in the United States scientifically, at least on a direct basis. Yep. So how did you arrange your fellowship? And obviously you landed in one of the foremost labs of Dr. Pitts.
Mostly by luck, I think. But anyway, I arranged through family connections, essentially, an internship in Milwaukee. They were short of interns. I think they needed about 8 or 10, and only 6 at that time, so I was accepted there. And got into the United States in that way, and had a very interesting and a good year, I think, in Milwaukee. I never thought it was a waste of time or anything. It was a rotating internship. A little episode that is sort of some humorous interest is that I arrived on late December and started January 1st in the delivery room. Now, I never had done deliveries in Vienna, obviously, with a large number of students. You did not get any hands-on experience. But there I was, and there I was supposed to deliver children, which I quickly learned from a third-year medical student to the extent, and actually I'm proud to report that I was in charge of a home for unmarried women and delivered some 30 babies. One of them might have been called Gerhard, I was told, but she was a girl. So I had a good experience there. I was in internal medicine. We had a very surgery. It was a good year. It was during that year that I then explored the possibility to get some training in renal physiology, which at that time was my interest. I even wrote a review for the Milwaukee Medical Journal on electrolyte.
As an intern.
As an intern, right. It was published.
Now, I know there's a little side story to your going to Milwaukee, because you had a pen pal who was from Wisconsin. I don't know if you'd like to tell that story.
Sure. One of my father's friends had immigrated to the States in the 20s and lived in Milwaukee, and that obviously why I ended up in Milwaukee. And my father explored the possibility for arranging for me an exchange of letters with one of his daughters. And there were 3 girls, and I think I was very lucky that the right one raised her finger, and we corresponded for 5 years. She was very interested in music, so I told her all about the operas that I saw, and she told me that she was immediately interested in chamber music. And 5 years later, we met actually in Vienna, and a couple months before I went to the United States, and that certainly was one of the reasons why I did end up in Milwaukee. After a year, end of my fellowship, my internship, we got married.
Okay, well, we'll return to Ilse's role in your career a little bit later. So here you were, intern in Milwaukee, and then we're exploring possibilities for doing research training.
Right.
And again, here you were without any direct personal contact with any of these famous individuals at that time. How did you make a connection that enabled you to get training?
I wrote letters of application to 12, I remember, individuals, and I think 4 of them made sort of little positive noises. And one was actually Bob Berliner, one was Bob Pitts, other one was Lou Welt, and the 4th one was, his name was Wright. He was in St. Louis. He was a good physiology professor, had done some physiology. And I got a letter from Pitts for an interview. And the others were sort of vague and were not quite sure whether they had the funds. Somebody who became a very good friend of mine, Lou Welt, didn't answer at all. I teased him about that. But anyway, Bob Berliner at the NIH would have looked at me, but I made a visit to Cornell, which was also funny because instead of East 68th Street as a very green New Yorker, I went to West 68th Street and didn't find the place of my interview. I had to run through Central Park to get there. So I was a little late, but Pitts was very nice. Dutifully, I had read all of his important papers before, so I was well prepared. He interrupted an experiment. I remember he was came out of the lab and chatted with me for 20 minutes and took me. My professor in Vienna had written a letter of recommendation, and also my boss in Zurich had helped me. So these 2 individuals gave it a little personal support, I think, that might have swayed him. But he accepted me, and I started the following year.
And what was the environment like in Pitts's group at that time? Obviously, he was internationally famous as an acid-base physiologist.
Right. That's also has also some humorous aspects to that, although at that time I didn't look at it in a humorous way. I distinctly remember that I came January 1st again to his office, and he was very nice. By the way, he was a very, very also stern person. It was you had to watch out with him, but I will come back to that. But anyway, he pulled up 4 containers with different dextrans. Now, you should know that Pitts, of course, was very famous for his work on acid-base balance, relationship of sodium, potassium, bicarbonate. He had done some basic work on acid production, and I had hoped, of course, that I would do something nice and interesting, let's say steroids on acid base or something of that sort. So he took out those 4 bottles of dextran, and which he had gotten from the Research Council. It was a time, I think, of the Korean War, and they wanted to have plasma substitutes and trying out how long these substances would stay in the blood and how quickly they would be excreted. So I was charged with doing a comparison, essentially, of 4 different charges, molecular weight 100, 25, 10, and 5, to get an idea whether they are useful. Had nothing to do with electrolytes. Now, failure was just around the corner because it took me months and months to get the right method. The Antron method, which was used at that time to measure dextrans, didn't work for me. I mean, the blanks were more green than the samples. Soon the technicians admired the green color and wanted to have dresses like that, and I was not entering this field, shall we say, in glory. I did, however, develop a method to measure dextrans. It was very complicated. You had to use an autoclave. It was cumbersome, but anyway, as you might expect it, the ones with the high molecular weight stayed longer, and the ones with the lower ones were excreted faster. But I did get a presentation at the Federation meetings with some positive comments, and after about a year or so, I had 1 paper to do that.
So you didn't get discouraged by your initial...
I did get discouraged. I remember long nights at home where Ilse and I talked about the possibility of going back to Vienna, but I didn't. I stuck it out. It was just too interesting because it was a vibrant laboratory, and I still didn't get to the kidney because my second project was an acid-base project, but it was on nephrectomized animals to see whether there are any shifts in electrolytes with respiratory acidosis and alkalosis that got published in the Journal of Clinical Investigation. So from then on, things were all right.
So we've talked about a couple of the projects you first worked on in Dr. Pitts' lab, but I know that in his role as a mentor, it was not only to get you started in specific technical projects, but in a way it opened up a world of connections for you to get to know people in the field. I don't know if you wanted to talk about that aspect of your training with Dr. Pitts.
Yes, because I think it's an important aspect was that he was really a center of attracting people from abroad, which gave the department sort of a special atmosphere and climate. Particularly, he had connections with German nephrologists who came to his lab for 1 or 2 years, about 3 or 4 fellows, and that was an important link to European nephrology in general. There were also people from South America who were coming, a couple Japanese. I mean, it was really wonderful to interact with them, and many of my later fellows who came were sort of initiated by these early contacts with the Pitts laboratory. One peculiar aspect in a way is that I didn't really work very much with him because, to his great credit, he left me he let me develop independently with some bumps because there was another project that didn't quite work out. I remember wanting to study brain volume receptors. At that time, there was the idea there was something in the brain sensing the status of the extracellular fluid, so I developed a carotid loop model where you could externalize the carotid artery and inject solutions of various oncotic pressures into the brain and measure sodium excretion at the same time. And I remember I did this for several months, and I always remember that never remained sodium excretion as constant as during my various manipulations until Pitts one day came in, and I always tell the story. I said, Gerhard, never pursue a problem that long. It's not good banging one's head against concrete for longer than 6 months. So I stopped that and went into other things. Actually did some clearance experiments on iodide. I forgot precisely what came out of that, but anyway, he left me pretty much alone before I started to do single nephron studies.
Right, so if we can turn to that. So obviously Pitts himself and his lab largely used clearance methods, metabolism at the level of the whole kidney. And you were one of the pioneers in studying transport phenomena at the level of the single tubule.
Yes.
So how did you, since that technical expertise wasn't available in Pitts's lab, how did you learn that and support yourself to learn it?
Well, I would maybe mention 2 aspects of this. In the first place, you're quite right that at that time the studies of discrete renal functions was dependent on clearance methodology, essentially comparing filtered amounts with excreted amounts and manipulating transport rates by varying plasma levels, etc., to manipulation like that. And that had reached a high point, I would say, with Berliner's work, with Pitts's work, Homer Swift's work, and some of their followers. Also clinical applications. Stan Bradley, for instance, did work at Columbia and that.
And Peters.
Peters' work, too. Now, therefore, I think you can get only that far by sort of what comes in and what comes out, because of course the nephron in between has many different sections, and you have to make guesswork, very highly developed guesswork about this. So the micropuncture, in other words, withdrawing fluid from various key points along the nephron was an essential further step. Now the technology of that was at that time constrained to essentially 1 lab or 2 labs. A.N. Richards was the sort of the founder of that, and one of his person who had worked with him, Phyllis Bott, was still sort of available to teach the technique. But how I got to this was actually in a roundabout way, because one of my early sponsors, Professor Deutsch, who was also interested in coagulation, probably that was one of the reasons why I didn't stay with him, came by and had read about Oliver's technique. In other words, Oliver was a pathologist at that time at Merck already, but who was the master sort of dissector of single nephrons, and he wanted to see that methods and asked me whether I could arrange this. So I asked Pitts to give a call to Oliver, who invited us. So I went down with Professor Deutsch, and he showed us those beautiful single tubules. And that, I think, what stimulated me that that's the way to do it. Now the question is, why why was potassium of interest? Because potassium was particularly nebulous. What happens along the nephron? You could show that it's either reabsorbed or secreted. So what would happen where was essentially the question. And Bob Berliner had postulated a certain mechanism of essentially all filtered potassium being reabsorbed and the excreted amount being dependent on variable secretion, and that you could only test directly by going at the nephron. So he was very good, that is Pitts, and he let me go to Philadelphia, to Phyllis Bott, for 6 months. And I remember that I learned to do micropuncture in her lab. I didn't work at a mammalian thing, but nephron, but on the amphibian species, on Necturus. And these 3 months I commuted. I went down to Philadelphia on Monday and came back on Friday and again left on Monday. And the second 3-month period will always remember it was terrible hot, and my wife Ilse was pregnant, but she came down for a couple months, and it was a hot summer. And but I got enough data again to settle a tricky problem, essentially whether the proximal tubule acidifies or not, because there had been different results from the amphibian work. But this was all amphibian studies. So after 6 months, I came back and set up in Pitts' lab and had hoped that I would work now with Pitts on problems of acid base along the mammalian nephron, where very little was known at that time. And to my great chagrin, he was not interested at all. He had at that time switched to be interested in the metabolism of ammonium and wasn't interested in single tubule work. Also, he used the stop flow technology to localize the real function, and sort of came mockingly down and said, well, we solved another one. I think that you could do it an easier way than puncturing by using the stop flow technology. But I was not deterred, and he bought all the equipment for me. And maybe I should say a little bit about the development of some of the analytic techniques. That was a key problem. And one thing that helped very much was the development of an ultramicroflame photometer. And again, reading was sort of the key of my getting some solutions to that, because on some long Saturday morning I browsed in the library and found a paper in a symposium report of Lorente Deneau from the Rockefeller Institute, where a German fellow had measured sodium and potassium on single nerve fibers. He stimulated them for a different time and then measured how much sodium was gained and potassium was lost. And his name was Paul Miller. He was originally from Cologne and had developed a very simple gadget, essentially putting the Ranvier's note, the nerve fiber, on a single platinum loop and putting it into a flame and then withdrawing in a flame with a little mechanical device and with a photomultiplier tube get the emissions. So I went down to Philadelphia again, where Paul Miller was located in the psychiatric research station, and he essentially helped me to build one at the shop at Cornell. The burner was very critical, which he made for me, and I'm forever grateful to him because it worked beautifully. And I was very proud. Later on, it was adopted by the 2 big European labs, by François Morel in Paris and by Karl Ulrich at the Max Planck Institute, and they improved it a bit. And that made it possible really to measure in nanoliter in very small fluid samples quite accurately sodium and potassium simultaneously by varying the filters and the emission. So that was quite important. So when we set that up, I had another stroke of luck because I had 2 terrific collaborators at that time. One was Gerhard Malnick from from São Paulo, who had written to Pitts and me whether he could come up. And I mean, he was an exceptionally gifted and skillful individual, and we still collaborate. We just had recently, last year, our last paper together. And the other one, I had a very able technician, Mrs. Ruth Close, who actually taught Gerhard Baldick how to do micropuncture. She had learned it from Dr. Windhager and myself, who had been working on that before. So the 3 of us worked for a couple of years and sort of did the shall we say, the basic localization of transport along the nephron with various manipulations. And there were so many manipulations that Bob Pitts once said, why did you do all these experiments? I think you just did them for Bob Berliner, so who was at that time the father of potassium transport.
Right. So, because of your ability to measure potassium secretion in the nephron, and then proceed from that to develop a cell model of potassium secretion, I know that intellectually there was a very strong link to the Using model of sodium transport.
Yes.
So I don't know if you want to mention
Yes.
how that intellectual link developed.
Well, I was again fortunate because my then collaborator Erich Windhager, with whom I actually went to medical school in Vienna, he had an internship like I in Milwaukee, because I told him there was an opening there, and then he actually went to Harvard and worked with A.K. Solomon, and he had visa problems and had to leave the country for 2 years and chose Using's lab, and actually went to Using and did the very seminal work on paracellular shunt transport with Using on frog skin on an epithelial structure, and he provided me sort of an entry to become acquainted with Using's work. As a matter of fact, Using at that time was not feeling well. He gave a Harvey lecture and he actually stayed with us in our house in New Jersey in Tenafly for 3 days. So I got to know Using quite well. And that was an important, shall we say, intellectual stimulus, because he developed essentially a cell model of epithelial transport where he took the basic transporters that were already known from red cells and other simple structures, and by strategically putting them in either the apical or basolateral membrane could account for net sodium transport. And if you modified that model and put a potassium permeability at the right spot, you could also try to explain potassium secretion, its dependence on the availability of sodium, its dependence on the electrical driving forces. And one important thing, of course, was you had to sort of open the black box of the epithelium and now try to see what transport properties are located either apical or basolaterally. And having done some electrophysiology first on amphibian nephrons to measure cell potentials, you then could determine the gradients apically and basolaterally. There was one nice episode that our model came out that was different from that of Dr. Berliner. Now, Dr. Berliner was the recognized expert and a very powerful and very central person in renal physiology. He was head of the NIH section of kidney and electrolyte metabolism, and I was a little worried that our cells scheme would find the approval of the great man. So with some trepidation, I took the train to Washington, went out to Bethesda and spent a couple hours with him, and he perfectly well accepted it and said he could, by the way, in his sort of to explain his original model at that time, the gradients were not known, and he just phenomenology made it likely that the sodium-potassium relationship could be explained by an apical ATPase that exchanged sodium for potassium, but that we had to shift it to the basolateral side. Anyway, that was the cell model then that finally came out of these studies, found his approval, and actually started a very long-lasting collegial and personal friendship with Dr. Berliner, who later came to Yale. He was dean in our place, and after his retirement was a member of our department. So I remember him always going over manuscripts and removing all split infinitives, and I could never repeat anything. And he was a man of short papers, and I learned a lot of writing from him because I had a tendency for long sentences that already Dr. Pitts.
So you mentioned, in essence, uniting with Bob Berliner here at Yale, and going back to the 1960s, obviously your work was flourishing. You had a wonderful environment in the Pitts group at Cornell. But then in 1968, you were recruited to Yale, and where you've been and flourished for the last 40 years. So what made you come to Yale at that point in time? What was it about Yale that seemed attractive, and how did moving to Yale ultimately affect your career and your ability to do science?
Well, I think it affected my career in a major way. Yale was attractive for a variety of reasons. First, it had a very strong clinical nephrology group with Frank Epstein, later Lou Welt and John Hazlett, and after all you came. But that was significantly later. But there was
Much
certainly
later.
a linkage. There was an important linkage to a strong nephrology and the tradition from Peter's days that still was sort of felt in the, shall we say, the intellectual curiosity in problems related to electrolyte transport. And the other point was that there were two members in the department whose work complemented my interest. That's Joe Hoffman, who done some seminal work really on red cell transport, the development of ghosts and the manipulation of cell content. In other words, it fit very well into what I was interested in. And the other one was Peter Kern, who came from Harvard and was a superb biophysicist who really knew all the equations and all the thermodynamics, and from the theoretical point of view was an expert in transport physiology. And I had known both of them, and they later become very, very good friends, and it was a wonderful environment for me. So I came, in other words, the chairmanship was not the primary
Yes, it should be mentioned that you were the chairman. You were
I was
recruited
recruited as chairman, and I was chairman for 5 years in rather busy time, 68. I mean, there was a lot of student unrest, but we got away all right. There was no, it did not interfere with what I was doing, but 5 years was enough.
So I always thought that you had the great insight to realize that you only needed to be chairman officially for 5 years, and then you could more or less steer the department without being the chairman for the next 35 years. So
my going away president of the department was a program project that lasted 35 years. So it was an ideal environment for me.
And so you came here before Bob Berliner had become our dean.
Yes.
And were
Just
you involved in
time.
his recruitment?
No, not at all. And it was, in a way, it was fortunate that I was not chairman, because he was rather, shall we say, very sparing in providing other people with money, and I did not have to go up to the dean's office and fight for money that was left to Joe Hoffman. So I got out just in time.
And so at Yale, as well as before, you've trained innumerable people, and I know I've always been impressed that anyone you ever trained, not only did so many go on to very successful careers, but they became lifelong friends and perpetual recurring collaborators. So there must have been something very special about your ability to mentor people, and I wonder if you could comment on what you think the characteristics of a good mentor. What are the characteristics of a good mentor, and in what way you found yourself able to be that successful?
Well, I think it's important to first not to use people to an end. In other words, don't abuse people. Don't let them work on a project where nothing comes. In other words, there's a way of wasting people's time, and there's a people to look at it from their point of view. And I always was very fortunate to get people with whom it was fairly easy to get along with. There were one or two exceptions, but on the whole, I was very, very fortunate in that way. And it was also a time when single nephron work was very popular. It was an explosion of interest in what the nephron really, methodologically, I mean, there was the availability of isotopes where you could measure individual ion fluxes. There was the development of electrophysiology where you could measure electrical driving forces. There was the development of ion-sensitive electrodes where you could monitor cell activities of various ions. I mean, and people simply, we were simply a place where that type of technology was developed and where there was interaction, and clinical fellows found their clinical environment across the street an additional attraction. And I'm just very fortunate in the people who came to my lab, and I think I let them do their stuff afterwards. I wasn't sitting on my problem and nobody else could work on it. I mean, these things. Somehow I was fortunate to steer my way so that some of them, as you correctly say, have become very dear and very permanent friends.
So as you mentioned, your initial work sort of mapping out ion transport along the nephron in terms of transtubular transport, and then by use of intracellular electrodes and ion-sensitive electrodes determining driving forces, and then at the last stage of your active lab career using patch clamp methods to study
Yes.
single ion channels. So you made multiple transitions of technology while still maintaining your productivity. Often people sort of get locked into a certain technique. So how were you able to do that? I mean, what was the secret, so to speak, of being able to transition methodologically while keeping the lab just as productive as always?
I think it had a lot to do with the environment. I mean, there were people who simply did patch clamp techniques on simpler preparations than an isolated tubule. I mean, Chuck Stevens was
Here
down
at Yale,
the,
you're talking about.
at Yale was down the corridor, and the availability of I think the intellectual climate where people in other areas were simply very stimulating to what was going on in our laboratory. And as I said, I was fortunate that the people who came were usually of a very high level from other physiology departments, or particularly also departments of internal medicine, or graduate students. I had a couple, like post-Stanton, for instance, that were very, very gifted individuals. So that made it possible to sort of keep always on the edge methodologically. But I think my early training with PITS really made me also want to put things back into the kidney and not just sort of methodologically be stuck with one thing and not use it. In other words, I tried to do reductionist type of things, but put them back into a system of the cell first, and then even of the segment where in the kidney, and then see what does it make sense, or how can we advance our knowledge of the overall processes, how the kidney works, by going down the system. And a good example of what was probably one of my most successful collaborations, with the exception of the Malnik team and that sort of early period. I don't want to mention too many names, then I'll leave somebody out, and then they are. I don't want to do that. But I should mention one collaboration, which was my collaboration with Steve Hebert. Steve Hebert was an extremely gifted and very active person who decided at one point boldly to go into genetics and clone some of these transporters, type of work I never did. And he was successful in cloning an important potassium channel. And about 10, 15 years ago, I just went up to Boston and said, well, how would it be if we could work together on some of the things? You have the technique, and I have other background in potassium transport. Let's work together. It was my initiative, and that was sort of late in my career when things could have gotten slower. I mean, it was another very important step that kept me active for many years, and it was one of my most satisfying collaborative efforts with a colleague who also became a very dear friend and very tragically recently died. But that was a wonderful way. I mean, we visited each other, we worked together, we published quite a bit together. So that was very complimentary and very good.
And you played a key role in recruiting him here to Yale as chairman.
Yes, that may have helped.
So you collaborated even before he was here, and then obviously that was
you
were
very
able to do
nice.
that more closely once he was here. I know that in addition to your research, that you always took teaching very seriously, medical student teaching. You took your responsibilities of being a professor as being more than just that Yale is a research institute, but that it's a school where people need to be taught and taught by professors. So I wonder if you could comment a little about your philosophy of education and your dedication to teaching over the years.
That again goes back probably to von Brücke, who was a superb teacher from my medical school years and who inspired me really in many ways. And then it was Pitts again. Pitts went to every lecture for the students. There were about 100 students at Cornell. They usually came. And he sat in the back row and took notes of every lecture for the 16 years I was there. I mean, it was an admirable thing. I mean, because you were judged by how well you taught, and I had to teach different things. I mean, I remember I had to teach at Cornell autonomic nervous system. I had to teach. One day he came to my office and said, "Gerhard, it's your job to teach respiration from now on." So I got this together. I went to some people at Columbia who were experts in respiratory physiology, and just put the lectures in and taught the respiration. Actually, I taught also respiration at Yale as well. So it was expected. As a matter of fact, your success in your academic advancement was partially determined by the way you taught. Pitts made another statesman, one of the few statements I did not agree with him. He said, I can get a good researcher every day, any day, but not a good teacher. So, I mean, you see, teaching was sort of, in the earlier parts of my career, was given a high importance.
Right, and you had, I guess, role models that really
yeah,
guided
Pitts
you in
was
that
a
direction.
superb lecturer, and so I think it came from that.
Now, one other way that you've done teaching was via textbooks, and of course, one of the most prominent textbook is the one you edited with Don Selden, who's
Yes.
a long-time friend.
Yes.
If you want to comment on how you met Dr. Selden and how you became such close friends.
Well, Dr. Selden, of course, is a well-known entity in nephrology, being chairman at Dallas and really having developed one of the best groups there, and has been enormously influential by training many people. Floyd Rector is one of them, and several
Might be
others.
pointed out that Dr. Selden had trained here at Yale with Peters.
That's correct.
Right.
He's and he approached me at one meeting of the Nephrological Society and asked me whether I would like to join him. And that was his initiative. And my first reaction was, well, there's already a good book out there, the Brenner book out. Why write yet another book? He said, well, ours will be different. It will be more physiological and more basic science oriented, and where the other one had a very strong clinical orientation. So I joined him, and again, it was the beginning of a wonderful friendship. He's a very, very dear friend of mine, and we put together 104 chapters, which was quite a job to get them all to come in at a reasonable time. But that's how, by the way, I made the acquaintance of many of my colleagues by trying to entice them for a book. And so the book is now in its 4th edition. We are not, Don Selden and I am not the editors anymore, but Bob Alpern and Steve Hebert are, much to Dr. Selden's chagrin, because it used to be the Dallas-Yale axis, and now it's just located at Yale.
Right.
But anyway, and that was also very instructive experience, because you again make contact with many people and learn a lot about other areas which you normally don't stay in contact with.
So in conducting your academic life, obviously incredible dedication to research, teaching, writing textbooks, many papers, being sort of an international statesperson for kidney research, organizing meetings all over the world. How did you interface that with your family life? Obviously, your wife Ilse often traveled with you.
Yes.
You have 2 wonderful children and have grandchildren now. How would you sort of, do you feel a tension between your professional and your family life, or do you have any comment on that?
Well, I think my daughter, as you probably know, Ilse died recently, and I think my daughter gave a little talk at the ceremony for her, where she said that I was doing the research and Ilse did all the rest. In other words, she was very understanding. I don't think there were tensions about my involvement. That was accepted. I mean, I probably spent, the children sometimes commented that they remember that I was always writing on weekends. So that must have been a strong component. But we shared many interests despite of my involvement in research. I mean, we were both, we really got together early through music, if you want to, in a way. And she was a very good pianist. She played chamber music. She had accompanied people singing. Actually, she wanted a musical career and then did not pursue that and became a clinical chemist. It was her, because her parents thought that was you could make a living that way, and music you couldn't. So she, but she pursued her own career later on by pursuing the Alexander technique, a muscle retraining program that she was very successful in and helped many people. And we worked it all right. We traveled a great deal together, and we had common interests. I mean, we went to the opera together, I mean, the musical events together, and she spoke German because she grew up, actually. Her first language, although she grew up in the United States, until the age of 10, she spoke German at home. So there was a certain link that made me, I learned a lot of English from her, obviously.
Your pen pal.
Pen pal.
Right.
So I think we worked it out all right.
Obviously, you have a very close family. Your two children live in this area, and
Right,
and you're close to your grandchildren, and
Yes.
so that's a wonderful.
Yes.
I think
I had
all-
a problem, obviously, with my parents. I was the only son, and my father died, and my mother stayed alone in Vienna for many years, and then got ill and was in a home, and that caused a certain amount of heartache and made me feel drawn to Vienna. So we spent many summers in general, or many time in Germany. They have some wonderful friends in Europe. I could go mountain climbing with 2 or 3 of
Right,
them.
I want to expand on that because it's certainly well known at Yale that every fall you would go mountain climbing with Heine Murer.
Well, Heine Murer is a special person because we tried to. He's one of your colleagues. He worked in an area very similar to yours, and I'll make you a compliment now. When we tried to recruit Heine Murer, you were extremely enthusiastic about him. You said, yeah, get him. Although he was your closest competitor, and that shows something about you that you were. I from then on I had great respect for your insight that you didn't consider research as a competitive activity, but one where very simply both are interested in how things work. I mean, that's so. Anyway, Heine Murer, we made Heine. He was a Swiss citizen and a very good researcher, and we made him an offer to come to Yale, and he had agreed. And then the Swiss finally found out how good he was and offered him a professorship. And from then on, we always teased him, and he accepts it, that he never would have gotten that had we not offered him the job here. And I once made a remark and said, "You owe me a mountain." And we started to go mountain climbing together for about 20 years now. And lately we have gone to the Dolomites because I once challenged him that he should also consider mountains outside of Switzerland. So we now go to northern Italy for the last 15 years.
So, and I guess I know also as the years have progressed and some major universities have actually de-emphasized physiology as a department. And I know you have very strong feelings about the importance of physiology as a basic science discipline and the importance of medical schools maintaining commitment to physiology. And I wondered if you would like to expand on that.
Well, I think in a way physiology has been so successful that certain branches of physiology have become independent, which eventually leads to the independent departments of genetics in some way, of neurosciences certainly. And I think one should not lose sight that the job of physiology is really to find out about function. And I mean, you can clone transporters and have, let's say, 15 isoforms, but somebody ought to look what they do. In other words, I think for a whole meaningful interpretation of many of the advances that are being made, one still needs, quote, classical physiology. By classically, I mean that your main interest is really how a given, shall we say, in my field, transporter works in the kidney, what turns it on and what turns it off. Consider, for instance, the great insight from genetic knockout models where you knock out one transporter, but then to your surprise, the phenotype may not be all you had expected. Other things are coming in now. What are these other things? How do they know that they have to come in now? That has major impact for understanding of pathophysiology, for renal failure. How does a kidney, for instance, that has only 10% of its glomeruli, how does it adapt? Or how does chronic acidosis lead to cellular changes that make it possible for the organism to survive this? In other words, the adaptive functions. All this at a sophisticated level of physiology, I think, is vital for really understanding. And I mean, it's being recognized, I think, for instance, all by the pharmaceutical industry that real physiology has its place in the whole picture of medicine. I think that's important for training because we ought to train people who can fulfill that function.
So nowadays, of course, right in the current environment is a little bit of a cyclical down period for NIH funding rates, and many people young people maybe a little bit apprehensive about dedicating themselves to research careers. Obviously, you derive tremendous satisfaction from your own career, and wonder if you have any advice on to offer future generations of physiologic scientists?
I think the NIH is a tragedy. I have been witness to 2 periods of downturns, in other words, when only a small fraction of approved grants are being funded. It's terribly hard on young investigators. We lose gifted people, and I think it is short-sighted. The American system, I once had to give a talk on comparing different countries with respect to pursuit of scientific endeavors. I mean, we are unique in the United States to have strong basic science reputation in clinical departments. I mean, a large amount of advances in renal physiology have been done in clinical departments. If we don't watch, we were going to lose that because people are discouraged. I think it takes great insight and great courage to pursue a purely scientific career. I mean, if you're an MD, then you still can, if necessity demands it, make a living. But as a PhD, things are being strained, and I hope that this is only a temporary downturn, and that reason will eventually lead to a more adequate funding of research endeavors.
But yet, as we went over the story of your own career, we'll sort of end with this, that in a sense you never had certainty going along the way. You started out, went to medical school, probably intending to be a clinician, and then you found your way to Pitz's lab and began some projects that didn't work right away. Even though the times maybe are a little bit better statistically for getting grants at that time, it was always uncertain, but you probably didn't worry about it. Or, no. So is that the ultimate message? If you do something that you really love, then you don't worry so much about the risk you're taking. I don't know if you want to.
Well, you have to take a risk. That is no doubt. I mean, if nothing ventured, nothing gained. Dr. Pitts, by the way, said that all the time when things didn't work out. I think you must have a deep interest in how something works. In other words, that for me was always the sort of a guiding principle, that I was genuinely interested in some biological process, and if you have that, then you pick the right mechanism or the right methods, the right place where to go, and ultimately we still have very good people working in many areas, and they somehow made it. But it is harder than in my days. I remember, maybe that's always a telling story. I remember in Pitz's lab, by the way, I did not have an independent grant for a while. He gave me money from his budget. There's a funny story, because I once ordered a power supply that turned out 1,000 volts, but of the wrong polarity, and we couldn't send the thing back, and he was very angry at me not to have checked it out what I really needed. But I mean, it shows that you get started, and then actually the NIH at that time came through various institutions, encouraged us to write an NIH grant. That's certainly different from what happens now. I came at the right time. I was very fortunate. NIH support was never a problem. But yet, very, very good colleagues of mine right now have problems. And it's a bad signal for the younger people, and we just have to muddle through until hopefully reason prevails, because it's one of the unique aspects in this country to encourage research, and particularly encourage basic research in clinical departments. And that was always an important aspect of our work, to have relatively close links with clinical research.
Well, I think that as we conclude, you just did that 1 year of clinical work as an intern, but certainly your work has always been very much informed by a clinical perspective, and and I think that those of us who work in physiology and those of us who've benefited here at Yale from your presence all these years are very grateful for your many contributions and for your support of the field and all of us as individuals. So thank you very much.
Thank you.